Hello and welcome to the C programming language course. This is part 1. In this tutorial, we will learn how the C programming language works, the basic C structure, and what do we need to start learning C programming. So first, I will be using the Visual Studio Code text editor, which you can download from the internet. So just search in Google Visual Studio Code and you will download the this text editor. If you don't want this or you don't have it, you can use another text editor of your choice, but I really recommend you this one because it makes life easier and it's a good one. So first, what is C? So C is a kind of old programming language, but it's pretty important. In order for us to start working with C, we need to have a C compiler, which will translate the C code we write into an executable that the machine can understand. So as requisite for this course, you will have to be running a Linux distribution and you'll have to install either the GCC compiler or the CLang compiler. If you are on a Debian-based distribution like Debian or Ubuntu, you can install the compiler in the following way. You can open a terminal. So Visual Studio has a terminal included which can be opened by pressing Control and the key that is just below the escape key. So you click that and the terminal opens and you press that key combination again and the terminal will be closed. So inside the terminal right here, if you are on a apt-based distribution like Debian or Ubuntu, so I really recommend you installing either Debian or Ubuntu, but if you're kind of more experienced, you maybe can do the same with another distribution. So what you have to do here is type the following. You will have to type sudo apt install clang, okay? I recommend you CLang, but you can also install GCC. So GCC, whatever you want, okay? So you will press an enter and complete the installation process, okay? I won't do that because I have already installed my CLang compiler. And here in the terminal, if you type CLang and press enter, it will say CLang error, no input files, which tells us that CLang is installed, right? Okay, so once you have installed CLang or GCC and Visual Studio Code, what we will do is we will start actually coding, okay? So right here in Visual Studio Code, we will create a new folder or open a new folder. To open a new folder, we will click on the File menu right here, and then we will go to Open Folder. And there in Open Folder, you will create a new folder. In this case, I'm calling this folder C1, okay? And you will press in OK, and your folder will be opened, right? So I have done that already, and here is my C1 folder, which is empty. The next thing we have to do is to create our first source code file. So here we click on this new file button, and for the name we will call it c1.c, okay, which means the tutorial number 1 of C. And the C files end with the .c extension, okay? So the file has been created right here, and we're ready to type our C program. Okay, the basic structure of a C program is pretty simple actually. So if we want to create a hello world program, we will do the following. We will start by typing $sign or hashtag, and then we will type include stdio.h, okay? So this is the way we include an external library or file to our C program. This will be the only library we will be including right now because it enables us to get input from the user and also output to the screen. So now we have to create the main function. To create the main function, we will type the following. We'll type int main, okay? And we will open a bracket right here and we will return 0. As you can see, this is the main function, and this is kind of the simplest C program that we can make. To format the document in Visual Studio Code, we can press Ctrl-Shift-I, and as you can see, it will be formatted kind of in a more ordered way, which is awesome. So right now we have our first program, but we want the program to print hello world. To do that, we're going to type printf. We will open parentheses and double quotes. We will say hello world. Okay, so this is kind of our first program we will print right here. So how do we run this program? Well, first we have to compile it, and then we have to run it. To compile it, we will open the terminal, and if we type ls and enter, which means list the files that exist in this directory, there we can see that we have our c1.c file. So if we want to compile that file using clang, we will do and type clang, and we will say c1.c. So clang space c1.c. We'll press and enter. The program will be compiled, and if we go and say ls again, now we can see that the compiler has created a new program which is called a.out. So that is our actual program that can be run on our computer. So to run that program, we have to do the following. We have to type ./a.out. The / means run the a.out program that is in this current directory, kind of saying local. Okay, we press on enter, and as you can see, the program prints hello world, exactly what we told to do. Now, as you may see, when after we print hello world, the new terminal comment is shown there, which we don't want that. So we want to show it in the next line. So to fix that, we will go to our code, and here in hello world, we will enter a backward slash and the letter N, which means new line. This means N escaped. Okay, so this won't be printed. The N won't be printed. What this means is please print a new line. Okay, so we're gonna save this one. We're gonna go to the terminal. We're gonna go again and say clang space c1.c, and as you can see, the program is compiled. And now to run it, we press ./a.out, and as you can see, now we print hello world and a new line, which is exactly what we want to do, which is awesome. Okay, so this is the basic workflow to code in C, which is pretty easy. We can make this even easier by creating a file that will contain the clang commands. Okay, so to create that file, we will press here new file, and this file will be called cc. Okay, which means compiler, kind of, yeah. Okay, and right inside this file, we're gonna type clang, and if we want to change the name, if we don't want the a.out name, we can change it here. So to change the name, we do the following. So we first give it the source file name, which is c1.c. Okay, and then we will press -o space, and now the output name. So -o enables us to specify the output name of the executable file. In this case, we will call it C1. Okay, we will save this file. We will switch to the terminal, and if we go and run cc by saying /cc, then it says permission denied. So we have to enable the program to run. To enable permission in Linux, the running execution permission, we will do the following. We will press chmod space plus X and the name of the program, in this case cc. We press enter, and now we press /cc. We press enter, and now the program has been compiled automatically. So now we have reduced the clang c1.c to just cc. If we list the directory by saying ls, we will find some files right here. So the first, which is a.out, we don't need it anymore, so we can remove it. To remove that file, we're going to say rm a.out. And when we do this, we can see that the file has been renamed. And the first file here is C1, which is our executable that was produced by our CC file. So to run the C1 file, we're going to say /C1. We press enter, and you can see it still works. So hello world. Now, to make this a bit easier, this IDE comes with an auto-saving feature. To enable that auto-saving feature, we will go to File and click here in Autosave. So you won't have to be saving the file every time you modify it, okay? So I have always that enabled because it's very useful and very handy to have. Now, if we have a lot of output in the terminal, we can clear the output by typing clear, enter, and as you can see, everything was cleared. Okay, if we switch back, we can now close the CC file because we won't need it. And as you can see, now we have our basic C structure. So how this actually works? Well, the main thing right here is actually this main method, okay? The int main method. So this method will be called by the system. So you always have to write a method that is called the main method because it is the entry point of your program. Okay, so the first word we have here is int, which means that this function, this method, will return an integer. In this case, as convention, we return 0. Okay, and inside these two brackets is what the method execution lines are created. As you can see, we have two execution lines right here. One is printf and the other one is return. Okay, so that's how we print text, which is pretty easy, right? Now, how can we print, for example, a number? Well, we can either print it as a text the same way, but saying, for example, instead of hello world, we'll print a number 4. If I go here and to run, we have to do cc, and then we have to do c1, and 4 is printed right here. Okay, but I want to print maybe a variable name. So, for example, if I want to create an integer variable name, I will do the following. I will type int number. The number is the name of the variable, and I will set this to 1000. And to end the line, we also have to end the line with a semicolon. Okay. Now, what if I want to use printf to print this number? Well, we will do it in a format way. That's the F in printf stands for. So we're gonna create double quotes here, and we will gonna type a %, a D, which means print a decimal number, kind of a number, an integer. And after this, we will print a new line. So as you can see right there. And here we have to pass the actual number, the argument. And to print a number, we'll say just number. Okay? So let me go through this again. So first we have defined our number as an integer variable, which has the value of 1000. Next we want to print that 1000 number into the screen. For that we call the printf and tell it that we want to print a number. To tell it that we want to print a number, we tell it %, and v. Okay? And we also tell it after you print that number, after you print that number, print a new line. This new line is just to make it look nicer, right? So you print a number and then a new line. And after that, we write a comma, and as the second parameter of the printf method, we pass the actual number we want to print. In this case, this variable, which contains the number 1000. Okay, so as you know, a variable is kind of a cell in the memory that stores a value. It can be an integer or a boolean or any other kind of value. So pretty easy, right? And then we tell it to return. So which basically means exit the program. We have done everything we wanted to do. So let's run the program and check if it works. So first we're going to go and say cc to compile the program, and then we're going to say /c1 to actually run the program. And as you can see, the number 1000 is printed, and in a new line is printed this new kind of a terminal prompt. Great. So we have done this, and this is kind of the basic way in which we execute a program. Okay, now let's see. In other programming languages we have comments. We also have comments in C. To create a comment, we have two ways of doing it. The first one will be by starting the line with 2 forward slashes. Okay, so remember, these are forward slashes, not backward slashes, which are different. So we go and type 2 forward slashes, and here we can type whatever we want. For example, this is the first C tutorial video. Okay, so that's a comment which the only function of it is for the person who reads the source code to know something useful about the source code. It's kind of an annotation, that it's kind of a note for yourself, right? Okay, but that's kind of a single line comment. But what if we wanted to create a multi-line comment? Okay, to create a multi-line comment, we will do the following. We will press 1 forward slash, and then we will enter an asterisk, okay? And that kind of defines where the comment starts. And we also have to define where the comment ends. And to define, we can go maybe lots of lines below, okay? And to determine where the comment ends, we're gonna also enter an asterisk and again another forward slash. And between these two symbols we have entered, we can write whatever we want. So for example, hello, I am a comment. Hello, I am a multi-line comment. And we can keep typing as long as we want, whatever the case may be, right? Okay. So this is a single line. The first one was a single line comment, and this is a multi-line comment, okay? Which is useful in some cases. Okay, awesome. So that was how comments work, right? So basically, in C, we have a couple of variables we have to know. Variable types. The first one, we already wrote it, was an integer. So an integer stores 4 bytes. So it needs 4 bytes. So occupies 4 bytes of memory. So this is just the size of it. You don't have to memorize it. So if you want to kind of use a smaller number, you don't need 4 bytes, because 4 bytes can represent up to 4 billion numbers, of the number 4 billionth, which is a lot, which you may need that, but sometimes you may need something smaller. Something smaller than an int is a short. So you can say short is the half of an int, right? So for example, short, I'll call it I am a short. I am short, for example. And this number occupies only 2 bytes, and this can handle up to, in signed way, it can handle up to, I think, 15,000. Let me check. I think it was 15,000. Oh no, 32,000. So short goes from, oops. So these variables can store positive and negative numbers. For example, this can store -4. The int one can also store negative. All of them can store negative. And this variable needs 2 bytes, okay, of memory. So, oh, and remember to end the line with a semicolon, right? So we can also write comments after we ended the line, as you can see right here. So that's an int, which requires 4 bytes, and this is a short, which requires 2 bytes. And we also have one that requires 1 byte, which is a char. I would call it char. And this can handle numbers between negative 128 to positive 127, okay? And this is 1 byte long, okay? So maybe if we want to order these guys, we will kind of change them and write first the smaller ones, and then we will write the larger ones. So we start with char, then we go with short, then we go with int. So if you guessed, if you wonder if there's a variable that needs 3 bytes, well, there isn't. So the smallest one is a char. The next one is a short. The next one is an int. Okay. And we also have a long. Well, a long is able to either hold 4 bytes or 8 bytes, which is kind of 64 bits wide. Okay. So as you may know, 1 byte is 8 bits. Okay, 1 byte equals 8 bits, right? And 2 bytes equal 16 bits. So 2 times 8. And 4 bytes equals 32 bits. So if we define a long, we can use up to 8 bytes, which are 64 bits. So basically that's how this works, but sometimes the C language, which is kind of old, in that time in where the C language or C specification was made, the longest size or bit width was 32 bits. So the long in some machines is 32 bits. So in order for us to access the 64 bits of the machine, because nowadays almost every machine is a 64-bit machine, we have to do and write long, okay? And this will be long. And as we are changing this, we can also change the number to int. And of course, when we print it, we also have to change it to int. Okay? So Great. And here in the I am long, we can set this to a very long number, really, because it can store really long numbers. So let me move this a bit to the left, to the right, actually. Okay, for us to visualize it better. So we start with 1 byte. So a char is 1 byte. Okay, a short is 2 bytes. An int is 4 bytes. And a long is 8 bytes, which is 64 bits. So the most used ones are the first 3. Sometimes you also require kind of 64 bits, but not very often, right? Okay, so we will do some experiments to know how this works. And as a way of doing these experiments, we will introduce the for loop. Okay? So we will introduce the for loop that will enable us to understand how these variables work in C. So to do that, we're going to create the following for loop. We're going to say for, we open parentheses and say int I equals 0, right? I less than 1000, for example, and I plus plus, which this is saying is run this loop 1000 times. So how do we specify this in this way? Well, we start with 0, then we go with 0 up to 999. So we have 999 plus the 0 state is 1000 states. And we will be incrementing this variable, the I variable. This means I plus plus means increment variable until it is less than 1000. Okay? And inside these, we will print the state of a character. So what we will do will be the following. We'll say print f, we open parentheses, we open double quote, we type %d \n to print a new line. And what we will print here, we will first starting to understand the char or the cart variable. So we're going to print I am char. Okay? And this means this will print 1000 times the character value. But we don't want to do that. But the problem here is that the character value, well, first we will initialize it to 0. But the problem with the character is that it's just 1 byte long, so it cannot contain 1000 digits. The highest number it can contain is 127. So it goes from minus 128 to 127, including 0, of course. So I will initialize this to 0, and I will print the character, and after every time I print it, I will increase the IAMCHAR variable. To increase the IAMCHAR variable, we do the same we did with the I variable. So you're gonna say, after we print f, we're gonna say IAMCHAR, and we'll press plus. We'll also say plus plus. We increase the value of IAMCHAR by 1. This is what plus plus means. Okay, so now let's compile this and check how this works. So you're gonna say cc to compile, and that's /c1. And as you can see, we have lots of numbers that the program has printed. And if we go to the beginning of the program right here, we can see that it starts printing with 0, which was the number we initialized the program to. Then it goes up and goes up and up and up and up until we reach 127, which is the maximum value. But what happened here? Since it cannot store more values, it carries the 1 to make it a negative number. And so it goes to the smallest number, or the largest negative number if you want to call that way, which is minus 128. And it goes from there down again, adding 1 until it goes to 0 again, and again it goes to 127, and then it goes again to minus 128. And this is kind of a integer overflow because it doesn't have more space. It doesn't have more physical space than its 8 bits. And the 8 bits can only store 256 values. That's why it goes back to the smallest number, right? So that's it for this video. I hope you enjoy it. In the next one, we will learn about the next data types and also unsigned data types, okay, which don't contain negative values. I hope you enjoyed the video and I see you in the next one. Bye.